Hey, what's happening, everybody? Mr. Mac here, and I thought I would do some solutions on this 4.3 challenge here. And why are these windows everywhere? Oh my goodness, enough. All right. So write a two-column proof for the given information. All right, so let's take a look at 18. And so again, a two-column proof starts with a given piece of information that we know is fact and asks us to prove another statement, and we're going to do this with giving some logical steps from what we know as given all the way through to the proof. And very often we're given a figure, and if we're not, we have to make our own. In this case, we're given this triangle ADC, and we've got two triangles inside. Okay, let's see what we got here. We got segment AB is an angle bisector of angle DAC, and we know that segment AD is congruent to AC. Okay, so statement one is we're just going to restate the given. So segment AB is an angle. Boy, my hand's not really, doesn't want to write here. Angle bisector of angle DAC, and AD is congruent to segment AC. Okay. And our reason for that is given. Okay, so I know I got some congruent stuff here. I got AD is congruent to AC. And number two, so I have side. That's all I got. So how does, I need to get another angle or a side or another two sides, an angle and another side. What does an angle bisector do? So an angle bisector, if I have this angle here, and I know that I'm given an angle bisector, well, that's going to cut the bigger angle into two congruent smaller angles, right? That's what an okay. So we updated our drawing, and let's see what we can do now. So we have side, angle, and in this section we saw two ways of proving triangle congruence. One is if we have all the corresponding sides are congruent, and the other one is side, angle, side. So we have side, angle, we need another side. So these two triangles here, ABD and ABC, they share something. What is it that they have in common? And that is this side AB. They have that in common. So we can write segment AB is congruent to itself. Seems silly to say that, and it's probably easier to see if we actually redraw the figure here, and then we could see, oh yeah, those two sides are the same. Something like this, and got A, B, D, and this is A, B, C, and we already know that, and we already know this, and so AB is congruent to AB. Yes, it is. And okay, so now can we prove it now? Yeah. How about can we prove it with Mocha? Let's prove it with Mocha. So now we're going to write the proof statement. ABD triangle ABD is congruent to triangle ABC. And why is that? Side angle side. Midpoint of segment DC and AD is congruent to segment AC. Prove triangle ABD is congruent to ABC. So same figures here, still same proof. We're just given some different things. So, you know, what do midpoints give us? A midpoint gives us two congruent segments, right? So let's start off with B is the midpoint. Of segment DC. Okay, and let's get a little asparagus over here, a little asparagus action. AD, segment AD is congruent to segment AC. My grandmother used to say any grass is better than sparrow grass. I kind of like asparagus. So reason is given. It's a pretty ugly green though, it has to be said. I don't know if I'm going to use that anymore. Okay, so B is the midpoint. AD is congruent to AC. You know what, let's redraw this thing. Redraw. Now, A, B, D, A, ABC. Okay, what do we got? AD is congruent to AC. Okay, we got those. That's what we had last time. Okay, 2. I'm going to stick with this color. What are we? Cayenne. Oh, it's a little hotter than the other one. Okay, so B is the midpoint of DC. B is the midpoint of DC. So if B is the midpoint, doesn't that mean that segment DB is congruent to CB? Yes. Why? Let's go doubles on this. So I'm going to update 2 drawings here. Why is that true? What's that definition of what? Midpoint. What's the definition of a midpoint? And we know that B is a midpoint, so we know we get 2 congruent pieces. Okay, and this line right here, aren't we sharing the same side here still? Yes, we are. AB congruent to itself. Okay, so that's reflexive property. Reflexive property of congruence. So that's triples. Okay, so now we have enough. We have 3 sides, right? What color should we go with? Maroon? Triangle. Kind of looks like cayenne. Plum. ABD is congruent to triangle ABC. So that's that side. All right. So, I mean, you can see it's just line 2, really, that's different with these 2, 18 and 19, and the given, of course, in 1. Okay, a couple different figures here. Number 20. Given B is the midpoint of segment DE, here's DE right here. B is the midpoint also of AC, that's this one right there. And we get a right angle. ABE is a right angle. All right, prove ABE. Okay, the yellow and orange triangles here. Speaking of orange, let's get our givens. B is the midpoint of segment DE and AC, really just scrunching it in there. And we got angle ABE is a right angle. ABE is a right angle. Okay, given. Okay, let's go, I don't know, blueberry. Now, so right angles are good. What about the midpoint? B is the midpoint of DE. So doesn't that mean that DB is going to be congruent to EB? And how about let's just continue. We know that B is also the midpoint of AC, so doesn't that mean that AB is congruent to CB? Okay, so why is that? That's a definition of what? Midpoint. Singles on that one, doubles on this one. Okay. What we got now? So I think we really don't need this right angle information right here. I mean, we can prove that these two angles here are congruent, can't we? I mean, what kind of angles are these, right? We could say that angle ABE is congruent to angle CBDD. And why is that? When we have two lines that cross, why are the non-adjacent angles here congruent? So to the V vertical angles. Vertical angles are congruent. Okay, so I mean, we can prove it now, right? Pretty straightforward. With a little magenta. So ABE is it congruent to triangle CBD. And why? SAS. Side angle side. Last one. And let's lavender. Number one. So I'm going to write segment DB is the angle bisector of angle ADC. And AD is congruent to DC. Kind of went over the line there a little bit. Given. Yeah, I don't know if magenta was a good idea. Okay, AD and DC. AD, you know what? DC, I think we can redraw this one again. Yes, I think that's a great idea. Let's separate our triangles. We're trying to prove ABD, this blue one and this other blue one, CBD, are congruent. Prove it. ABD. And we got CBD. I hope you see that there's something being shared here. Spoiler. Okay, so what could we say here? Let's work off of this angle bisector. So DB, this thing right here, is bisecting ADC right here. So what does that mean? It means that I hit Command Z and I get a spinning wheel. So that means that I get two congruent angles. ADB is congruent to CDB. Right? We're saying this angle is congruent to this angle because DB is a bisector. So that's definition of angle bisector, right? It's just not picking up all my drawing here. I gotta press harder, I guess. Right? So let's update the drawing here too. So already that one was from given, and then those are congruent. So we have side angle. Okay, so eggplant. These two triangles are sharing a side. What are they sharing? BD. They share BD. So BD is congruent to BD. Reflexive. It's kind of like reflection, right? You see yourself. Reflexive property of congruence. Boom. Okay, let's wrap it up. What color have we not used? Spring? No, it's too early for that. It's getting close to winter. Let's go nickel. Triangle ABD is congruent. Here's our proof statement. Triangle CBD. I just throw doubles on that. We got enough. What is it? SAS. Okay, I hope these are pretty straightforward for everybody. It says challenge, but we only had 4 statements. You did have to write everything and do the drawings, etc. So it's a little more challenging. We're just incrementally gonna, take on a little bit more with these kinds of proofs. Okay, so I hope that was good, and I'll check you guys later.